Hey everybody, just wanted to give a quick update on the calculator program. There will be a calculator at school with the AP Physics calculator program on it when you arrive for the test. A number of people have been asking me though over the last couple of days how they could get the calculator program on their own calculator, and so I wanted to show you how to do that very quickly. So I just want to be clear about one thing here at the start. You access the program by pushing the program button. If it's on your calculator, it'll say Phys List. Then, of course, you're going to hit enter twice, and the program will be open. The point that I'm trying to make here now is that if you clear the RAM, which I'm sure you all remember how to do, you push second and then plus and then 7, 1, 2 if you have a normal Texas Instruments calculator. You clear the RAM. When you hit program, it will be gone. You want to make sure you have fresh batteries in your calculator when you're doing this, because if you don't, then you're not going to be able to have access to the program when you want it. If you clear your RAM, it will be gone. So I'm going to show you very quickly how to get this program on your own calculators from home. The first thing you're going to want to do is go to Google and type in TI Connect calculator software. The first thing that comes up is going to say TI Connect software, US and Canada, and you're going to click that. Now, of course, you'll see a download button, and then in the corner there, it says TI Connect for PC, TI Connect for Mac, and if you scroll down a little more, it says get the right version, TI-84 Plus family users. If you want the correct version, just make sure you click on that and make sure you got it. The version that I need, because again, I have a TI-84 Plus, is that version TI Connect CE. I'm pretty sure that's for all of the newer calculators. You can definitely tell the difference here because the icon for the program has these two little arrows that look like that. And for the regular TI Connect software, the arrows look like that. So you're going to click on that, you're going to download the software, you're going to open it up, and it's going to look like this. It's a pretty basic program to use. My calculator is not plugged in. You're going to need that wire here, which is the straight USB, and then to this little calculator attachment and whatever that's called. I don't know. It seems that none of my other devices have a plug exactly like that. You plug in your calculator and it automatically pops up. I don't know if you heard the click when I plugged it in, but that was it. It's recognized my calculator. It's a TI-84 Plus. It's got version 2.55 of the OS. We're in business. Doing this is very easy. You go to Actions. You hit Add Files from Computer. And when you add the file called AP Physics 1 Formula List, this screen is going to come up and it's going to say name on calculator is going to be Phys List. It's going to be installed on the RAM. There is an option here to store it in the archive. I'm not exactly sure. Obviously, I know the RAM gets erased when you clear the RAM, but I don't know if it works if you install it in the archive. I don't know. You could figure that out on your own, I guess. It says select calculators. My calculator is there. And that's it. I'm going to hit send. That program is on my calculator now. If I come back here, remember, I cleared the RAM so it was gone, and I push the button that says program. There it is, Phys List. So here's how you use the program. You turn the calculator on. There's a button there that says program. It should be next to VARs or whatever. So you hit the program button. That comes up. It says Phys List. You hit enter. So that would be down here, enter. And then enter again. And there's the program. It says pick subject, kinematics, dynamics, gravity, uniform circular motion, energy, momentum, rotational motion, and then 7 is for more options. My recommendation, use the number pad. Pick the appropriate one you want rather than trying to use the arrows. The arrows work on the main screen, but once you pick a subject, the arrows no longer work, and that makes this kind of annoying. I think maybe to make this a little easier, I'll just prop this up here so you guys can see it. Maybe that's worse. Maybe I'll just turn. Okay, there we go. So here's what I mean. When you're on this screen, you can use the arrows to move around. But let me click on a long list in particular. Gravity and uniform circular motion is a little long. There you see you've got a number of equations. Let's say you want to go to the next page. Down arrow. Doesn't work. You have to make sure you push enter. When you push enter, then you scroll through the list. And if you keep pushing enter, once the list is done, you'll eventually get back to the main page. When you hit 7 for more options, there's simple harmonic motion and waves. Now, of course, waves not in the course anymore, so you could just ignore that one, but I want to just show that for a moment because this one is 3 pages long. So we hit the down arrow, nothing. You got to hit the enter button. When you hit the enter button, you move through the list, and then you get back to the screen. Now, it's not a hard program to use, but there are a few annoying things about it. On this screen, the arrow keys work, but nowhere else. My recommendation, stick to the numbers. The only other thing that really needs to be said is this button here, 3, which again, I would use the button 3 down here, is to get back to the previous screen. You want to quit the program, you got to push 7 to get to more options, and then 4 to end the program. Once you do that, it'll say done, and you'll be back at your main calculator screen. My recommendation is the second you do that, hit clear. Why? Well, because if you accidentally hit enter again, it's going to open the program right back up again, and then you'll have to hit 7 and then 4 to end the program. If you just hit clear, now notice if I hit enter, it is going to end up opening back into the thing, but once you hit 7 and then 4, clear it out, type in anything else, then it's just going to work like the normal calculator. Again, all you have to do to access it is hit program, and then once you open the program, you're good to go. Notice here, I'll just run through real quick, although you could figure this out. Kinematics, you got your average velocity equation, delta x over t. You got an equation for displacement. Notice this is just average velocity times time, where average velocity for an accelerating object is initial velocity plus final velocity over 2, and then of course times the time, and then you have your range equation for the projectile. Notice the only thing missing here is the angle theta. This is supposed to be v naught squared sine 2 theta over g. That's a mistake. Of course, you can blame the kid who originally wrote this, but of course, he's the only reason you have this. Free body diagram, notice it says here you take the sum of the forces that are positive minus the sum of the forces in the negative direction. The acceleration being positive usually refers to acceleration up. Negative acceleration usually occurs to negative acceleration down. Remember, we take ma, we set it equal to the forces going in the direction of the acceleration, so that would be positive, minus the forces going in the opposite direction. Then you have here your normal force for an elevator problem. The normal force is equal to m times a plus g. You got fgx and fgy for an inclined plane, and then force in terms of momentum, delta p over t. Okay, moving on. Gravity, you've got your contact radius 111 rule problem. If you remember, a 111 rule problem is a 111 rule problem, like normal. However, if they give you that problem where you have the two spheres that are touching, and it says they keep the density the same, but they increase the radius, you had to account for the fact that the mass and the radius were changing. All you have to do is take the factor by which the radius is changing and raise that to the 4th power. That's what this equation is for. You can always tell it's a 111 rule problem because of the prime. If you forget what this is about, then I would suggest watching that video again. This equation, of course, is the equation for the acceleration due to gravity on the surface of a planet, gm over r squared. Then you have that equation written in terms of the density of the object. Remember, density is mass over volume, and so if you substitute that in there for the mass into that equation, you end up getting this, 4/3 g pi rho, the density, and then times r. You have your speed of an object in orbit equation, 2 pi r over t. You hit enter, you go to the next page. You got your centripetal acceleration equation. That's not in the reference table. You got your centripetal acceleration for an object in orbit. Notice that really just takes the 2 pi r over t equation and subs it in for v. And then you got Kepler's laws. Kepler's law is not officially in the course, but there, I think, they could be useful, maybe not, whatever. You go to the energy page, you got the potential energy for a pendulum. Remember, when you raise up a pendulum, all that matters is the change in height. The change in height is given by the equation L minus L cosine theta. That's going to prove itself to be very important, I think, because they've been asking that more and more on the test. You got your equation for the work due to friction, not in the reference table. Also, work due to friction equals final energy minus initial energy. And then you've got power equals work over time. force times distance over time, of course, because work is force times distance, and then force times velocity, because, you know, d over t is v. Okay, cool, moving on. Now we go to momentum. There you've got your defining equation for elastic collisions. V1 minus V2 equals the negative of V1 prime minus V2 prime. You got your equation for the lost energy in a collision, Ke final minus Ke initial. And then you've got your equation for the fraction of lost energy, and that would be the change in kinetic energy over the initial kinetic energy. Moving on, rotational motion. You have your translations between linear and rotational, so V equals R omega. Your tangential acceleration, A tan, equals R alpha. Your radial acceleration, R omega squared. And then your relations between torque and angular momentum. Torque equals I alpha. That is in the reference table. I'm not really sure why he put that in there. But also, you've got your L equals I times omega. And of course, because omega is V over R, you can write it that way as well. And then lastly here, we go to 7, more options, simple harmonic motion. You got your equation for the velocity of a spring block oscillator, your maximum velocity for a spring block oscillator, and then the total energy, 1/2 Ka squared plus 1/2 mv squared, your total energy spring potential plus kinetic, and then maximum velocity, omega times the amplitude, maximum acceleration, Ka over m, and then of course omega squared times the amplitude, and that is it. Remember, always push 4 to end the program, and then hit the clear button to clear it out. All right, guys.